All right, so we have the quotients of powers property. Of course, quotient means divide, so you can see we have b to the m divided by b to the n equals b to the m minus n. You can tell it's a quotient because you see the division problem. What you're going to do is you're going to collect like terms, keep the base the same, and then subtract the exponents. So let's start out with a pretty simplistic example. Keep the base the same, which are your x's. So you have x. And then you're going to subtract 10 minus 2. And 10 minus 2 is x to the 8th. That should be familiar from pre-algebra. You can see how this all works, why this property is what it is, in my complete notes that are in the extra support row of your lesson plan grid. So let's move on to a more difficult example. So as you can see, I need to collect like terms. I have some coefficients, I have some a's, and I have some b's. So when I go to write this, I'm going to split it up into my like terms. So I have 30 divided by 10 multiplied by a to the third over a to the second, and then multiplied by b to the sixth divided by b. So first and foremost, I'm going to do, I've got that 30 divided by 10 right here, so I'm going to do 30 divided by 10, and 30 divided by 10 is 3. Then I got this a to the third divided by a to the second. So a to the third divided by a to the second is a to the 3 minus 2, which is 1. And then last but not least, I have the b's. I have b to the 6th divided by b, so I rewrote it here, b to the 6th divided by b. There's not an exponent here, so we know if it's not there, it's a 1. So I keep the base the same, and I subtract 6 minus 1, which would give me 5. And now I just multiply those together, which there's no like terms to collect or anything like that, so I just do 3a. I probably wouldn't put to the first because we know it's to the first, b to the 5th. Done. Let's look at another example. This one is just a little different than the last. Again, I collect my like terms. So first and foremost, I'm going to collect my coefficients, which would be 2 divided by 8, multiplied by, collect your a's, which would be a to the 5th divided by a to the third, multiplied by, last but not least, b to the 9th over b. And again, it's just a b, so I can make that b to the first. Now, the only difference is here, I really don't, it doesn't come out evenly that I have 2 divided by 8. So instead, I leave this as a fraction. I find the greatest common factor, which would be 2. So I'm going to divide them both by 2. So 2 divided by 2 is 1. 8 divided by 2 is 4. So that's 1/4. Multiplied by, keep the base the same, subtract the exponents. So 5 minus 3 is 2. And then keep the base the same and subtract the exponents. So 9 minus 1 is 8. Now, I kind of talked about this in my last video, but this is where it's going to come into play, where it's really important how you write this. You really have this a squared all over 1, and you really have this b to the 8th all over 1. So if you look at this and you multiply the whole entire top row, you have 1 times a to the 2nd, b to the 8th, which would be just a to the 2nd, b to the 8th, all over. And then you have the bottom row, 4 times 1 times 1. Remember, these are all multiply. So 4 times 1 is 4. So this is the best way to write your answer, and that's how I would like you to write it. A squared, b to the 8th, all over 4. I know this means the same thing, but as you can see, it looks like the a squared and the b to the 8th are in the denominator. So that's kind of confusing. And I know that 1/4 is the decimal 0.25 or 25 hundredths. But when we do quotient of powers, we don't usually put a decimal. So again, I know it means the same thing, but I don't want to see it that way either. This would be your final answer.